Hey everyone, and welcome. In this explainer, we are going to take a deep dive. We're going to go from the JavaScript functions you already know and unlock the really powerful tools that make modern web development tick.
Okay, so here's the plan. We'll kick things off with arrow functions, then sort out the this keyword. After that, we'll look at recursion, callbacks, and wrap it all up with promises. Let's get started. All right, section 1, the upgrade. We're talking about a simpler syntax with arrow functions.
So let me ask you something. Does your JavaScript code ever feel a bit, well, clunky? A little verbose? If you've ever typed out the word function for the 100th time and thought, there's got to be a better way, well, you're absolutely right, and you're not alone. So what is an arrow function? Well, think of it as a super compact, shorthand way to write a traditional function. It lets you write code faster, but the real magic trick, the thing that makes it so powerful, is that it doesn't have its own this context. And trust me, that's a huge deal. It solves one of the most common headaches in JavaScript, which we're going to tackle next.
Okay, look at this side by side. On the left, you've got your standard traditional function. It works, it's fine. But on the right, wow, look how clean that is. The arrow function just strips away all the boilerplate. No more function keyword. For a single line like this, you don't even need the curly braces or the return keyword. It's implied. It's just so much more direct and readable, isn't it?
Moving on to section 2, the context puzzle. This is where we solve the mystery of the this keyword. And here is the absolute game changer. In a regular function, the this keyword is, well, it's a bit of a shapeshifter. Its value depends entirely on how the function is called, which can lead to some really frustrating bugs. But with an arrow function, it's predictable. It doesn't have its own this at all. It just inherits it from the code around it. That means this is always what you think it is. No surprises, just reliable code.
Okay, section 3 is the loop alternative. Let's talk about a different way of thinking with recursion.
So recursion, what is it? It's a technique where a function just calls itself to solve a problem. It works by breaking a big problem down into smaller, identical pieces. The key, and this is absolutely critical, is that it has to have a base case, a point where it knows to stop. I love the Russian nesting doll analogy. You open a doll, find a smaller one, open that, find another, until you hit the smallest one that can't be opened. That's your base case. Without it, the function would just call itself forever.
Let's make this real with a classic example, the factorial. When you call factorial 4, it doesn't solve it right away. Instead, it says, to solve this, I need the answer to factorial of 3. And factorial of 3 does the same thing, calling factorial of 2, and so on all the way down. Each of these calls gets piled up on what's called the call stack. Once it hits the base case, factorial 0, which just returns 1, the whole thing unwinds. The 1 is passed back up, multiplied, passed back up again, until the very first call factorial of 4 finally has its answer. It's a really elegant way to solve certain problems. All right, time for section 4, functions as arguments. We're about to get into the power of callbacks.
So, a callback function sounds complicated, but it's really not. It's just a function that you pass into another function as an argument. The whole idea is that the outer function will then call your function. It'll call back when it's ready. It's like saying, hey, go do this thing, and when you're done, run this piece of code for me. It's fundamental to handling tasks that don't happen instantly.
Let's look at a practical example to see why this is so useful. Imagine we have a function called getGrade. It takes a percentage and a callback. Its main job is to figure out the grade, right? But once it has the grade, it passes it to the callback and lets that function decide what to do next, like generating a comment.
And this is where the magic happens. We have one function, but we can get multiple outcomes. We could pass in an English callback to get feedback in English, or we could pass in an Urdu callback for Urdu. The core getGrade logic never, ever has to change. It just does its job and hands off the result. This makes our code super flexible and reusable.
Now for our final section, section 5, mastering time. This is all about handling the future with promises.
Okay, so what on earth is a promise? It's an object that represents something that will happen eventually. Think of it as an IOU. When you ask for some data from a server, you don't get the data right away. Instead, you get a promise. It's a placeholder, a promise that you will get a value back sometime in the future. Either you'll get the data you asked for, or you'll get an error telling you why you couldn't.
Every single promise can be in one of 3 states. It starts out as pending. That just means the work is still in progress. Then it will eventually settle into one of 2 final states. If everything went well, it becomes fulfilled. If something went wrong, it becomes rejected. Simple as that. So how do we deal with these outcomes? It's actually really clean. You use the .then method to tell your code what to do when the promise is fulfilled, when you get your data. And you use the .catch method to handle things when the promise is rejected, when an error occurs. It's a beautiful, straightforward way to manage success and failure. So why does any of this matter? Well, for one, it helps us avoid something called callback hell, which is just deeply nested, impossible to read code. Promises improve the whole logical flow. They give us a clear central place to handle errors. And they make it so much easier to chain multiple asynchronous actions together. It just brings order to the chaos. Look, at the end of the day, this is how we handle asynchronous operations. And that's not a small thing. It is a cornerstone of all modern web development. Mastering these ideas is what lets you build truly powerful, responsive applications.
Thanks so much for joining us for this explainer. You now have the tools to take your JavaScript to the next level. So the only question is, what are you going to build with them?